Good morning, everyone. Can you hear me? Victoria, can you hear me out there? Okay, give me a second. Okay, hi, I'm Josh Crosby from Zero Base Energy. I'm going to tell you about our project of hybridizing the 3kW TQG, the Tactical Quiet Generator, to increase its efficiency, decrease its maintenance, and combine those generators together to gain more output from a small 3kW. Let me hit that. Okay. In 2010, Zero Base created the H series, which you see on your left, which is a larger hybrid power system using a foldable solar array, lead-acid batteries, and a fiberglass unit that folded out and could be deployed for the Marine Corps for spot power on base camps. In 2015, we worked through the Army's Rapid Equipping Force to develop the THG, which is a tactical hybrid generator. And it's a bolt-on kit to the current TQG that it basically doubles its power capacity output and makes it a hybrid generator immediately as soon as you bolt it on, and also decreases its fuel by 50% on day one. Since 2010, you can see the industry, so hybrid energy, battery, solar, everyone has been innovating to develop expeditionary power uses. So the weight reduction since 2010 has been about 7 times. Cycle life improvement by 5 times or more. Fuel savings improvement of at least 2 times of what it was in 2010. And now we're capability with new and legacy generators. So there's old generators in the field, and then there's new generators being developed, one mainly the AMPS program, that the hybrid power companies are learning to integrate with, learning to control better. Next. Okay. Yeah. So Zero Base started in 2009, basically working with the NSA, U.S. Marine Corps, and then on with the Army. We worked with Bill Garland at the REF with the Energy to the Edge program, and we've been integrating these systems and fielding them since 2009, and we've got over 200 systems in the field right now in Afghanistan, Iraq, and other locations. We started, like I said, with the H series, and now we've got systems down to 40 pounds that are a 350 watt output, all the way up to a 100 kilowatt microgrid that fits in an ISU 90 container. So we're meeting needs from small portable power all the way up to the microgrid level. The THG came from the Rapid Equipping Force as needing a hybrid system to connect to a 3kW TQG because of the maintenance issues, because of the power output issues, and because of the fuel uses. Because mainly where these systems were, fuel was difficult to find, it was dirty, and it was in dirty environments. So they were having a problem with keeping the generators running. So they needed something to hybridize the generator where it would reduce its runtime, increase its fuel efficiency. So that's kind of where we started. Is it switching? There we go. In the Army and the Marine Corps, DoD in general. So PM Force Sustainment Systems mission, you can read up here, I'm not going to read them to you. But they're all to increase energy efficiency, to reduce fuel usage, to reduce sustainment costs, to reduce the footprint of a base camp or equipment out in the field. So that's what we're all working toward, and that's what the THG accomplishes. We work with the Rapid Equipping Force, and the Energy to the Tactical Edge methodology is to identify and understand requirements, which we did. So the requirements were we needed to reduce the fuel and give the generator time to be maintained. We established partnerships with other companies so we could integrate the best technology at the time into our current equipment. We selected those solutions, we equipped the units with those, we get feedback from those, and we assess the impact of that so that we can go tell that good news story, which is what I'm telling you today. And then we inform the community. Hybrid technology adoption challenges. Unwillingness to rely on solar alone. A lot of folks understand that solar is not the only solution, or that maybe they don't want to rely on it because I've heard people say, well, the sun doesn't always shine. Obviously not, but that's why you have batteries. The perceived risk of advanced batteries. People are afraid of lithium, quote unquote, technology because of failures that have occurred with lithium cobalt batteries where they overheat, where they blow up, where they burn. The advancement in the battery technology has allowed us to use technology that doesn't explode, doesn't burn up, and can operate in really hot and really cold atmospheres or environments. The COTS components need hardening. So there's all kind of inverters and batteries and solar controllers that are commercial off the shelf, but they're not hardened for a military environment. So that's one thing that Zero-Base and other companies can do, is work with those companies to harden that equipment. There's no baseline for operator training. If you go and take a hybrid system into the field, there's not a set way to train how to operate a hybrid system. So that's another fear or a questionable thing that the Army and other DoD components have. The test protocols are not defined. So when we take these systems to ATEC to be tested, they don't know how to test it. They test it like a generator. So we've had to help them understand that this is not a generator. It doesn't burn fuel all the time, and there's different ways to test it. And then obviously sustainment, because there's not hybrid generator mechanics out in the field, so the systems we develop have to be self-sustaining. This is an example of one of our forge units powering a mortar pit, where you have the 3 Pelican cases here, and it's powering the communications and the GPS systems for the mortar system. This is the same thing you can see highlighted there, is a forge system connected to a 3 kW TQG powering the containerized weapons system. We've got, I think, 5 of those right now being powered by the forge system, and they can even be powered by the smaller Forge Lite 2K system. But all that, you can see, takes up a footprint of a pallet. The THG, which is what we briefed here last year, and now the TH3, which is a tactical hybrid 3-phase generator, its objectives were to take 3 kW TQGs, combine them together to have 12 kilowatts of 3-phase 208 output. And that's what we're here to tell you mainly about, is the ability to take 3 already fielded 3 kW TQGs, combine them together to get a 12 kilowatt output generator that provides 208 3-phase. It can be catered to any voltage or any phase level as well. All the components of the system are man portable, basically 2 or 4 man portable, and the TQGs can be removed from the system so that if you want to remove it to do maintenance, you can put another one on and just keep running. Next. Technology challenges and solutions is you got to combine unsynchronized AC sources. This is just getting into the techie part. Converting the generator output of DC using PF corrected DC-DC converter. So what that means is you got a bunch of generators that are producing a 120 volt output, but we connect to the NATO port, so we're using all the DC power so we can use it most efficiently to work with the batteries and then output the phase and the voltage that the customer required. We needed high energy density to get a lot of power in this small footprint that was light enough weight that it could still stay within the 4-man portable envelope. We use lithium ferrous phosphate battery power that had been tested by the Marine Corps, and then we charge with a charge and discharge rate of 2/2C. Okay, there you go. So here's a picture of the systems being tested. So you've got the tactical hybrid generators up on top of the THGs, and then all those will be connected to the TH3, which is all in the same footprint of the rack for the current 3 kW TQG. So they all connect together to form the 12 kilowatt generator. So this is in 2014, the forge connected to the 3 kW TQG, and what we've done now is replace it with this, to where the THG actually fits on the bottom of the 3 kW TQG, and then you add the TH3 module next to it, and you can connect, I think, up to 5 of the TQGs to this unit to get a 12 kilowatt output. Here's some of the attributes of it. I can just let you read over these, but basically it's doubling the output. You're getting immediate 50% reduction in fuel. You're getting a cleaner signal, so you're not getting the up and downs and the different voltages and the unclean signals from the generator. The system actually cleans all that up, so you get a good signal out. And then you reduce the duty cycle of the generator tremendously, which extends its life, allows you to burn less fuel, allows you to do more maintenance on that generator to extend its operation life. Flexibility is the same footprint as the 3QG, same material handling because we use the same rack that the generator actually sits on. It can be retrofitted to fit any 3 kW TQG or 5 kW TQG. It can be separated for man portability, and the THG only adds 308 pounds to the current generator, which weighs 308 pounds. You can see here some of the fuel savings. And then the applications, where do you need this thing? Anywhere where fuel is at risk. So is your fuel supply hard to get to? Do you have a dirty fuel supply? Where the system is mission critical, so where you have systems that cannot go down and you can't rely on the generator to stay running all the time. And then where delivered cost of fuel is high. So I'll stop there, and if there's any questions.
Yeah, Josh, that was a great description of the technology. Yeah. But so, you know, for innovators, there are obstacles to innovation, and part of that is you're going against the status quo. Mm-hmm. So in this case, hybrid power, renewable power, and you're competing against the fossil fuel generator. How did Zero Base overcome some of those obstacles of inserting and the acceptance of innovation?
So the standard out there is you always go to the Army guy to get your generator, and everybody knows that, and everybody knows that technology. With hybridization, you're inserting a technology that people really don't understand all the time. They don't exactly get its use. They think that, oh, you're just adding more equipment to my list. So part of that is looking forward into the Army requirements and seeing what they really need, working with groups like the Rapid Equipping Force, like SOCOM, and seeing what the next requirements are going to be, and then working with innovators, working with different battery manufacturers, solar manufacturers, inverter manufacturers to create a system, and then showing it, displaying it, and then also using it in the field to show that, hey, it's not adding any maintenance cost, it's not adding a sustainment footprint, you're actually reducing your fuel, you're reducing your transportability, and you're increasing the generator efficiency.
Yeah, you're hitting that. But so, I mean, having watched your company grow and having watched, so the big thing is trying to get the institution to move off of a great capability or an innovation was difficult. But what they did is they inserted it where there was a need, and so the end user is driving the requirement.
Right.
So for some of the people out here with their innovative product is that a good model? Is go to the end user, listen to the end user. Our old boss liked to use the expression, moving technology at the speed of a conversation. If you can have a good understanding from the end user what they're going to use, what they need, you'll have more success.
Yeah, and that's exactly right. I mean, for anyone innovating or inventing something, it's best to work with the guys actually using the equipment, because no offense to the officers, but they're not actually on the ground using the equipment. And so that's been a great asset of ours, is being able to work with the generator mechanics, to work with the soldiers running the comms equipment, running the mortar pits, and being there with them. I've personally been on a lot of these expeditions where I've worked with, you know, Special Forces guys, Navy SEALs guys, and see what they actually do day to